Hello, fellow Scratchers! Welcome back to part 2 of our online multiplayer Scratch game tutorial. Today we'll be pushing past Scratch's cloud variable limits, looking at how to smooth out our cloud player's motion and beginning to add the exciting online code ready to handle that large influx of players waiting to join your game. Now you know, once this series is done, we'll have to organise some official dates and times so that we can jump on Scratch together to play through the best of your shared online projects. That will be fun. But where were we? Yes, before we begin coding, let's take a look at why our player movement isn't yet smooth and what can be done about it. If you remember from episode 1, our player moves in a forever loop at 30 frames per second. Nice! And we diligently set our cloud variable 1 to the position after every move. The problem is, Scratch's cloud rule number 2 states that Scratch will not send cloud variable updates faster than 10 each second. Therefore, 2 out of every 3 updates are being lost in the post. The end result is choppy movement at a mere 10 frames per second. Well, 2 solutions spring to mind. We smooth out the missing animation frames in code using position tweening. This can work well for some game styles like Slither.io, but in a platformer, it leads to a rather unnatural, floaty movement that doesn't follow our players' movements exactly. So instead, we will use motion buffering. This doesn't rely on any guesswork, instead recording our players' exact movements in a buffer, a Scratch list. Then this data is packaged up every 3 to 4 frames and sent in a single cloud variable update. Well, since no position data is now lost, we are able to play back each player's movements exactly as they were recorded. Perfecto! The other feature we're going to be working on today is extending our multiplayer code to support player joining, so no more of that pressing 2 key. Nice one. So, load up your projects from where we left off in episode 1, and now is a good time to save it as a new copy, for this is episode 2. Guys, let's get scratching! As our project grows, it will be best for us to separate the player sprite from the multiplayer sprite. This will make it simpler and easy to backpack into other Scratch projects. So name our first sprite My Player, and then duplicate it, naming the copy as Cloud Player. This will become our backpackable Cloud Engine sprite, but we'll begin by tidying up the My Player sprite. Click back in there now. All we want to keep is the simplest player position script. So we can delete the when 2 key press script, goodbye, the read numbers custom block, be gone! The set encoded string and following blocks, thank you for your service. And lastly, the write number script. Aha, so we sure cut that down. Time to start building it back up. We always begin with initialization scripts to set things up. Broadcast and wait, with a new message, cloud setup. Now we want to record the player's motion. This will now be, as we just talked about, into a Scratch list. Name the new list My Values to send, leaving it for all sprites so it can also be accessed by our cloud sprite. And we add the current sprite's X position and Y position to that list. The result, if we smash the green flag, is our list gets flooded with new X and Y positions at a rate of 30 per second. And yes, it's currently growing out of control. But once we start sending this data over the cloud, we'll also be removing items from the list to keep it under control. So, broadcast, a new message, cloud tick. And we'll let the cloud player sprite take on the rest of the work. This way, our main game code can stay in this sprite, but all the cloud-related work gets done in the cloud player sprite. Great, we'll move on to the cloud player sprite now. And first things first, we can strip out any unnecessary scripts, deleting the green flag script, and yes, even the when 2 key pressed script. That only leaves our beautiful encoding and decoding scripts. Make sure not to delete these, but you can scroll them off screen to give more space to work in. When I receive cloud setup, make sure we hide this sprite as we begin with no visible cloud players, and then delete all of my values. We don't want any previous game movements being included in a new game. We'll add more to this setup script as we go, But for now, we'll move on to the when I receive cloud tick. This will trigger 30 times a second, once after every player movement. But this time, we only want to encode and send the player movements once every 3 or 4 broadcasts. Now, to keep track of this, make a new variable, naming it cloud tick for all sprites, and we'll change it by 1 each tick of our game. Next, to prevent triggering until the 3rd or 4th frame, we'll use a mod block. If cloud tick mod some number of frames is greater than 0, then stop this script. Now, if we were to place a 4 in here, the mod block would cycle the cloud tick around in counts of 4, resulting in this guard condition only letting our code below execute every 4th frame. Okay, to make this extra clear, I'm going to wrap this in a custom block. Name it send my cloud data after, with a number input named count. And another label, ticks, run without screen refresh. We can make use of this block here and fill out the number of frames to wait for, 4 frames for now. Then plug the count input into the right side of the mod block, like so. It would be nice to test this as indeed counting off 4 frames correctly. So how about we delete all from my values, only temporarily, as that will help us to see things are working. Now smash that green flag. And there we go. Our my values list is only filling as far as the first 4 pairs of x and y values, before it is being reset by our delete script, ready to be refilled once again over the next 4 frames. Great test! But rather than simply deleting these buffered x and y positions, our goal is to first encode and then send all that data to the other players of our game with a single cloud update. Start by removing that delete all, and instead prepare to encode our values by setting encoded string to the empty value. We want every item in our list to be encoded. So repeat for the length of the my values list. Then simply write out the first item using our beautiful custom block, write number, item 1 of my values, 2 in the encoded string. After it's written, we can delete that first item from the list. What I love about this trick is that any remaining items in the list will move up to take its place, so we can continue looping around, processing the first item until there are no more items left and every item has been encoded. Well, hurrah! All that's left to do is set our cloud variable, cloud1, to our fully encoded string. And it must be testing time. Smash that green flag! Okay, this is cooler than it looks. The my values buffered list is filling up in cycles of 4 frames as before. But this time, when it fills, we can see that cloud1 is then set to a much longer encoded value. That looks very promising indeed. Obviously, what we'd love to see next are these values decoded in other browser windows. Then we can finally see that smooth player motion that I promised you in action. Well, we are having to start over with our player2 scripts. So let's piece together what we will need to do. We load the project and notice that the cloud variable is already set to some value, probably left over from another game, so we just ignore it. Meanwhile, in another window, another player is already moving around. And boom! They have recorded 4 frames of motion and updated the cloud variable. This causes the cloud variable in our first window to also change, and this is our trigger point. It's this change of value that we need to look out for, as it tells us another player is active and playing the game. How do we know if a cloud variable has changed? Aha! We keep a record of the previous value of that cloud variable in a list. Then, if any cloud variable is different from our recorded values, then someone must have changed it. So scroll up to our setup script, and oh, talking of setup, we should have initialized cloud tick to 0. Right, we'll make that new list, cloud values, for all sprites. This will record the last known values of all the cloud variables. And we delete all of cloud values before we begin. Now we are only using one cloud variable at present, so add that to the cloud values list, cloud 1. If we run the project, we can confirm that it appears, and as the cloud variable subsequently changes, we can now tell encode by comparing these values. Except there is one slight complication when it comes to Scratch and comparing very long numbers. Here is a script I prepared earlier. I'm setting val to a number that is 250 digits long, just shy of the 256-digit cloud length limit. Tell me, does val equal val in this case? Well, I should hope so too. And as you might expect, it doesn't equal this other random number. But, and this is where it gets a bit weird, does val equal itself plus 1? Well, of course not. Except, apparently it does! To understand why, you'd have to know that when Scratch compares values, it assumes you are doing a numeric comparison on two numbers, which we are, and so Scratch tries to do the maths. But these numbers are so big that in doing so, it loses some of the precision, and the result is that the two numbers appear the same. The only safe workaround is to force Scratch to compare the values as text strings instead, by cunningly joining a letter onto the start. These are no longer pure numbers, so Scratch treats them as text values, and the comparison is all good. So let's do that, and join the letter C with the cloud1 variable. As we begin using more cloud variables, we'll have to come back and add them to this list too. Okay, so we know another player has sent this message, but how do we know which player it was? Gosh, it could even have been us changing it, right? A valid option would be to encode each player's username in with the rest of their cloud value. But remember how we are testing our game? Multiple windows with the same user logged into each. No, we need a unique identifier for each Scratch window, even when the username is the same. Not a problem. Make a new variable named myplayerUID for all sprites. This will hold the player's unique ID. Then at setup, set myplayerUID to a pick random lock with a random number between 1 and 9,999,999. That should be large enough to make it practically impossible for two players to be assigned the same number. Every time we run the project, we get a brand new ID. Brilliant. We just need to tag this on to the start of every cloud message that we send. Down in the send my cloud data script, drop in a write number block immediately after the encoded string is first cleared, and pop in the myplayerUID variable. Sweet! Now we can begin to watch for changes to our cloud variables. Scroll up to the when I receive cloud tick script, and we'll add in a new custom block, process cloud item, with a number input, which, then another label, value, and a second number input, new value. Remembering to tick the run without screen refresh block. Okay, so we'll use it before we try to send our own cloud data. That way we can check for changes before we overwrite the cloud value with our own player data. We'll start with the only cloud variable we are using, cloud variable number 1, and pass in its current value, but remembering to also join it with the letter C so it can be accurately compared. Cool, and we'll do that now. If the new value of the cloud variable is still equal to the last recorded value, which is stored in item which of cloud values, that will be item 1, then if they are the same, then we can ignore it. This is not a new cloud communication, so stop this script. But if it was changed, well then, that's more exciting. I wonder who changed it. But don't jump the gun. If the cloud value has changed, we should update the cloud values list so it too has the latest value. Replace which of cloud values with the new value. We can see this in action by running the project, and now the cloud values list is also being updated as the cloud variable changes. Cool. So the cloud variable has been updated, and we want to know who updated it. Let's decode it and find out. Set encoded string to the new value of the cloud variable, and then set encoded index. Not the first letter of the encoded string this time, but the second. Do you know why? Because we have to skip the first letter C, of course. Therefore, we start on the second letter. Val equals read number from encoded string. This will pull out the first encoded value, and that will now be the sending player's unique ID. Yes, that's exactly what we wanted. Now, there are two cases where we might want to ignore a new communication. If val happens to be less than 1, then this is not a valid ID and something has gone terribly wrong. But otherwise, this is the second case. If UID is equal to my player UID. Yes, we also will be detecting our own cloud messages since we share these cloud variables. So in both of these cases, we stop this script. Otherwise, we'll end up seeing another copy of ourselves walking around the game. Funky, but not what we want here. It would be nice to give this a test at this point. So to allow us to see another player's UID, make a new variable naming it player hash for this sprite only. And just for the time being, set player hash to the val, the other player's UID. Before we test, go back to the setup script and set player hash to that empty value. Right, do you remember how to test the projects side by side? We have to make sure the project is saved, and then load up 2 browser windows for the same project. And run them both. What you should find is that the left window's My Player UID, my unique player ID, is now showing up in the right window under the player hash variable, and vice versa for the right-hand window. Well, this is excellent! This shows that each player is able to send their unique ID across the web, and the other projects are able to decode and display it, ignoring their own cloud updates. Yes, they are both aware of each other's presence. The next step is to be able to identify if this is an existing or a new cloud player. In other words, have we seen this player UID before? To keep track of players, we'll have a new list named Player UIDs. As we decode a cloud message, if this contains a UID we've not seen before, this is a new player, and we add them to the list. Not only that, but we also introduce a second paired list, Player Data, in which we stuff the full cloud message. This ties the player UID to their latest posted data, ready for processing later on. The technical name for this pairing is a data dictionary. If, on the other hand, the decoded UID does exist in the list of players, then all we need to do is update the player's data with the up-to-date cloud message for that player. Job done! Shall we code that? Make that new list, Player UIDs, and leave it for all sprites. Then, to check if we've seen the UID before, we will use the not item 1 of list, no, but the very funky item hash of list block. And the variable val contains the player's UID that we just decoded. A result of 0 indicates that the UID isn't yet in the list. Indeed, it starts empty, talking of which we should ensure it does start empty by scrolling up to the setup script and deleting all of the player UIDs list. Okay, so now we can use that player hash variable correctly, and that is to set player hash to the value given by the item hash in list. So, like I said, if this player hash is equal to 0, then this is a new player we haven't seen before. We add them to the list. Add val to player UIDs. And now we need our second list. Make a new one naming it player data. Also for all sprites. Whenever we add to the player UID list, We also add to the player data list to ensure that they have the same number of values. We add the full cloud data value from the new value input variable. Now, to handle existing players, player hash will be set to the item number of the matching player's UID. So we just need to replace the actual cloud data over here. Replace item of player data, again popping in the new value cloud data, and it's for item number player hash. But when we have a new player, we are setting the player data to the same value twice, here and here. We can simplify that. Initially, let's set it to blank instead, and then ensure we set player hash to reference the last item in the list. That's the length of player data, the row we just added. Now, the replace below handles both new and existing player data updates. Cool. A final cleanup. Set player hash to an empty value at the end of this script. This will be important going forward, and I'll explain more on that later. So just before we test, make sure to reset the player data list in the setup script. Delete all of player data. And it's testing time! I'd recommend making the data list larger so that we can see the full content. And then save the project and bring up two windows side by side. Don't forget to reload that right-hand project if you kept it open from last time. Okay, what do we see? Each player's unique ID has been shared with the opposite window and added as a single new player to the UID list. As we move our mouse around, their cloud data is finding its way into the player data list too. If I bring my mouse over to control the second window, we see the player data now being updated in the left window instead. This is excellent and shows these scripts are coded correctly. Of course, if you are curious like me, then you might be tempted to see what happens when a third player joins the game. Just open a third browser window, and then I'll stop all three and click the green flags one at a time. There! Did you see that? Every player is aware that there are two other players communicating with them now. As I move over each window, the other two correctly identify which player is communicating and updates that player's player data. The crazy thing is, this will work to scale, way up to tracking over 100 players, believe it or not. But man, don't try to open 100 windows on your own PC. Even running 2 or 3 windows puts a lot more pressure on your PC than just a single player alone, and it might result in your game running just a little bit slower. Something to bear in mind while you're testing. Now then, it's quite exciting seeing these data values flying around, but not half as exciting as it will be to see the players actually moving around on our screens, yeah? But I'm sorry to say, that will have to wait until our next exciting episode, where we will be implementing the Cloud Player clones and handling their buffered movements. That's when all our hard work will finally come together. Well, I do hope you're enjoying this series, and if you are, then please do smash the like button and don't forget to subscribe and click the bell icon so as not to miss the next video the moment it drops. We're going to have so much fun, I'm telling you. Let me know in the comments how you're getting on and what you're going to use this multiplayer engine for. And I'll see you next time. Thanks for watching, have a great week ahead, and scratch on, guys.